Alright, so today we're just going to look at what happens at plate boundaries. So this comes up quite a lot, generally near the start of paper 1, in one way or another, generally a 4 or a 6 marker looking at one of the plates or maybe looking at all 3 of the plate boundaries. Now, we've got 3 plate boundaries. We've got the destructive plate boundary, we've got the conservative plate boundary, and we've got the constructive plate boundary. Now, all 3 of these plates, they all move due to the same thing. Alright, that same thing is always down to convection currents in the mantle of the Earth. Now, what we've got to remember is that the Earth, this is going to be a very inaccurate diagram, but we've got the core of the Earth. Now, obviously, that is there, the inner and the outer core. We've then got the mantle. And what these convection currents are, is they are where this molten magma is being heated up and then rising up to the Earth's crust. As it moves up, it gets cooler and then it'll start to sink back downwards. Now these things are happening, these convection currents are happening all the time in lots of different ways, but as it's getting heated up, it is going up. As it is cooling down, it will start to sink back towards the core. Now these things cause the plates to move. Now remember, the plates are at the crust of our Earth. So it may be that I've got a crust here and a crust here. As you can see here, this mantle is rising and then moving towards our right. So this plate here would move to the right, whereas this one here is being forced to the left, which would then cause the crust of the Earth, where these plates are, to start to move. Okay, and they are called convection currents. Now, whenever you are asked about any sort of plate margin, if you start it off by saying convection currents cause the plates to move, you're straight away there getting the examiner's attention and gaining some marks. Okay, so the first one we're going to look at is this destructive plate margin. Now, this one, you've got your 2 plates. We're going to use arrows to show the plates. We have got your oceanic plate, which is the denser of the 2 plates, and you've got the continental plate, which is the lighter plate of the 2. Now, in order to get full marks, or a high level mark, a level 3 answer, you'll need to know some examples. So the example of an oceanic plate is the Nazca plate, which collides and meets with the South American plate. And this South American plate is where the continent is, which is the continent of South America. Okay, and I'll write that there. That is our continental plate. Now, this all happens, main places happens in Chile, in South America. And what happens is you've got this dense oceanic plate. It's dense, it's got an ocean on top of it. When the 2 plates collide, the oceanic plate actually starts to subduct, which means goes underneath. Okay, it's always the denser plate that goes underneath. So the dense oceanic plate subducts. And by using that word subducts, you're using key geographical language there to get those extra marks under the continental plate. And what happens as this moves down here into what we call the magma chamber is this Nazca plate, or this oceanic plate here, will start to melt in its very intense heat. As it starts to melt, it will get hotter. Thinking back to our convection currents as well, something that is hot will rise, and then up here you will get a volcano forming. These are very destructive volcanoes. Okay, that's called composite volcanoes. Very destructive, very dangerous volcanoes. And also, as this plate goes underneath this South American plate, you get friction. As the 2 plates are rubbing together, that creates friction. That friction will lead to quite violent earthquakes as well. So you also get here volcanoes and earthquakes forming. Okay. Now, at our conservative plate boundary now, okay, conservative, so slightly different this one, because this one you can have one of two things happening. You can either have two different plates moving the same way but at different speeds, or you could have them moving in opposite directions. Alright. Now an example of this is the San Andreas fault in North America, and also in Haiti as well. They're the two quite famous conservative plate boundaries. Now the main difference here between the conservative and the destructive is it creates earthquakes only. I'm going to write that big letters so we remember that that is earthquakes only. And the reason being for that is because we get no magma here. There is no magma. Now, as the plates move, they get stuck. As they are moving past each other, the plates get stuck. Now, that's because they are moving at different speeds. Alright, so they will get stuck. And as they get stuck, friction will start to build up. Friction will build up. And over time, that friction will eventually basically reach what we call a snagging point or a breaking point. The bit that is holding it on will eventually give way under the amount of pressure that it has got, and that will then lead to an earthquake. Okay? Because all that pressure has been released, and that will create your earthquake. Again, there is no volcano here because there is no magma. On to the last one, we've got our constructive plate, and Iceland is a really good example of where we find a constructive plate, and that is where our two plates are moving away from each other. It's ultimately how new land is formed. And a famous example of this, is I'm just going to draw a line here, is the Mid-Atlantic Rift. Mid-Atlantic Ridge. Okay. And this is actually creating Iceland at the moment. So Iceland is fairly new, fairly new island in the grand scheme of things. And over here we've got the North American plate. North American plate, which is moving west. And then we've got the Eurasian plate, which is the plate that we are on, along with most of Europe, which is moving to the east at around about 4 centimetres a year. And what happens here is the plates pull apart, or the plates move apart, due to those convection currents down here. As they start to move apart, fast flowing magma can start to break through the surface. And that is what creates your new land. This also then creates something called a shield volcano, which are a little bit less destructive, a little bit less dangerous than our composite volcanoes that we get over here, but they can still be quite dangerous as well. Okay, and this also, as the plates are pulling apart, they don't pull apart nice and smoothly. You also will get earthquakes, but these are generally mild earthquakes. Not too dangerous. Okay. Now you do need to know what happens at all three of these plate boundaries. The question could ask you about one of them in particular, or it could say to explain how natural hazards form along plate boundaries, something like that. Hope this has been helpful.